Today we will start about the base standard efficiency of Otto cycle. As we know that Otto cycle mainly works on the principle of the petrol engines. Now, Otto cycle is mainly used in the petrol engines. Okay, before going to the derivation of base standard efficiency of Otto cycle, so first we let us know what is PV and PS diagram. Okay, in this PV diagram we can say that the process 1 to 2 is an isentropic compression, whereas 2 to 3 is a constant volume of isobaric process, and 3 to 4 is isentropic expansion, whereas 4 to 1 is a constant volume process. In this PV diagram, the heat addition takes place from the process 2 to 3, the constant volume also I take as Q1, whereas the heat rejection takes place from the process 4 to 1. So that we can say that the heat addition and rejection process both takes place in the constant volume process in the Otto cycle. Okay. So as we know that this is the TS diagram, temperature entropy diagram, this is the pressure and volume diagram. So 2 to 1, 1 to 2 again is isentropic compression, whereas 2 to 3 is the constant volume process. 3 to 4 is the isentropic expansion, and 4 to 1 is a constant volume process. So you can see the process here. 1 to 2 is isentropic compression, 2 to 3 is a constant volume process where the heat addition takes place. So I take it as Q1. And 3 to 4 is isentropic expansion, and 4 to 1 is a constant volume process. Okay. Now let us derive the efficiency of Otto cycle. As I told that efficiency of Otto cycle or anything, the efficiency is given by the formula work output divided by input. Output divided by input, or also we can take it as work done divided by heat supply. Work done divided by heat supply. So as we know that the Otto cycle efficiency can be written as work done can be written as heat supply can take as Q1 minus heat rejected Q2. The Q1 minus Q2. The subtraction of heat supplied minus heat rejected is given as a total work done divided by Q1. So now again separate term, efficiency of Otto cycle is equals to Q1 divided by Q1 minus Q2 divided by Q1. So Q1 get cancels. So efficiency of Otto cycle is equals to 1 minus Q2 by Q1. Okay. So now as I told that otherwise we can also take this equation. This equation I will take it as equation number 1. Now, as I told that the heat supplied during the process 2 to 3. So I will take the Q1 is equals to heat supplied. Q1 is equals to heat supplied. The process is a constant volume process, that is 2 to 3. So I will take it as 2 to 3. So now I take Q1 is equals to M mass. So it is a heat addition takes place in 2 to 3, that is the constant volume process. So I take it as CV, and you can see the temperature 2 to 3, the temperature highest temperature is T3, so I take T3 minus T2. MCV T3 minus T2. This I take it as equation number 2. Similarly, I go for heat rejection Q2. So heat rejected. So you can see that heat rejected during the process, as I told that heat rejection also takes place during the constant volume process is 4 to 1. So I take this as 4 to 1. So now similarly Q2 is equals to M. The heat rejection also takes place in a constant volume process CV, and you can see that here also same, you can see the temperature. So T4 is greater temperature and T1 is lesser temperature. So I take it as T4 minus T1. Okay. So T4 minus T1, this is equation number 3. Now we have derived the heat supplied and heat rejected. Now substitute the values of Q1 and Q2 in equation number 1. Substitute 2 and 3 in equation number 1. Now efficiency of Otto cycle is equals to, so now Q1 is taken as MCV T3 minus T2, MCV T3 minus T2. Now minus heat rejected is MCV T4 minus T1 whole divided by, again Q1 is given by the formula MCV T3 minus T2. This is the efficiency first I have to consider. Next, separate the terms. Now separate the terms. So we get here efficiency of Otto cycle is equals to, separate the two terms. First separate this term, next with this term. So I get MCV T3 minus T2 whole divided by, this one is MCV T3 minus T2. Again I will separate these terms. minus MCV T4 minus T1 whole divided by MCV T3 minus T2. Now what we should do is here MCV get cancels, T3 minus T2 minus cancels, here MCV get cancels. So that I can write efficiency of Otto cycle is equals to this entire term get cancels. So I take 1 minus, here is you get T4 minus T1 divided by T3 minus T2. This is the first important equation. You should consider this equation. I will consider as equation number 4. Okay. So first I have taken the formula for Otto cycle efficiency. Next one I have taken the heat addition process. Next is heat rejection process. And next I substituted the heat supplied and heat rejected in this formula. Next let us study about the how to determine the T4 minus T1 divided by T3 minus T2. So I will go for this process. First we have considered the heat addition and heat rejection process. Now we will move on to the isentropic compression process. Now from PV diagram process 1 to 2 is isentropic compression. So we know that for isentropic compression, that is compression TP ratio, that is T2 divided by highest temperature. You can see here is T2 by T1 is equals to V1 by V2 to the power of gamma minus 1. This I will take it as equation number 5. This is for the isentropic compression. PV ratio T2 by T1 is equals to V1 by V2 to the power of gamma minus 1. Similarly, when we have considered the isentropic compression, similarly now consider the isentropic expansion. Now I will take again for isentropic expansion. It is from the process. You can see the diagram of isentropic expansion takes place from 3 to 4. So I will take it as 3 to 4. Now the highest temperature is T3. So I will take T3 by T4 is equals to, now write the inverse of this one, that is V4 divided by V3 to the power of gamma minus 1. As already I told in the previous derivation that, so this V1 by V2 is equals to V4 by V3 can be taken as R, that is compression ratio or expansion ratio. So I can take V1 by V2 or V4 by V3 can be taken as R. So now what I will do is I will consider equation 5. In equation 5 and equation 6. So this I take as 6. I can write like this: T2 by T1 is equals to, so in the place of V1 by V2 I told that you can take it as R. So I take it as R to the power of gamma minus 1. Similarly in equation number 6, the equation number 6 you can see that I can write like this: T3 by T4 is equals to, again V4 by V3 can also be written as R to the power of gamma minus 1. In these two equations, we can see that in this equation and this equation, one side is R to the power of gamma minus 1 is same on the both the side. So I can equate the one side. If one side is same, so I can equate the other side. Now I equate the two equations here, so I can write this one as T2 by T1 is equals to T3 by T4. So this is one equation. I take this important thing. As I told that, take this to V1 by V2 as R and V4 by V3 is equals to R. So I can take this as T2 by T1 is equals to R to the power of gamma minus 1. Similarly, T3 by T4 is equal to R to the power of gamma minus 1. One side is same, so that I can equate on the both the sides. So I can take this one as on cross multiplication. See here, on cross multiplication I take this side and this one here. Okay, so what I will get here is here. So I can write this one as T4 divided by T1. T4 by T1 is equals to T4 divided by T1 is equals to T3 divided by T2. Now for my simplification, what I will do is I will assume I will minus 1 on both the sides. So I will take like this here, 1 minus T4 by T1 is equals to, similarly this side I take 1 minus T3 by T2. If I take this, there will be no any changes on the both the sides. If we cancel this, I get the same here. Okay. So I take 1 minus T4 divided by T1 is equals to 1 minus T3 by T3 by T2. Now I take LCM here. So if I take LCM, what I get here? T1 minus T4 divided by T1 minus T4 divided by, here what I get here is T1 is equals to, again taking LCM. So I get T2 divided by T3 divided by T2. Okay, understood this one? So I am taking LCM here. I am taking LCM. If I take LCM, here I have 1. So I want to get T1 here. Multiply T1 here. Similarly, I multiply T1 here. So here also same. I have 1. So multiply by T2. If I multiply by T2. So I get T1. 1 into T1 is T1 minus T4 divided by T1. Similarly, here 1 into T2 is T2 minus T3 divided by the LCM is T2. Now what I will do is, on cross multiplication, this will come down and this will go to numerator. So now what I get? T1 minus T4 divided by T2 divided by T3 is equals to, I take if cross multiplication T1 comes here, so I will take it as T1 by T2. Okay, understood this? So T1 minus T4 divided by T2 minus T3 is equals to T1 by T2. Now see here, we will do a slight changes here. In this equation we have T1 minus T4, T2 minus T3, but in this equation we have T4 minus 1 divided by T3 minus T2. So what I will do here is, I want to bring this into this form, so I take minus common here. Okay, how I take minus common here is here. So here what I do here is, here I take minus common. If I take minus common, minus into plus it will become minus, and minus into minus plus it will become plus. So I can write like this, minus T4 by T1 whole divided by, again in the denominator we take minus common. If I take minus common here, so I will get this as T3 minus T2 is equals to T1 by T2. So now you can see here, in the numerator we have minus and in the denominator we have minus, so you can cancel this one. So I can write that T4 minus T1 divided by T3 minus T2 can be written as T1 by T2. This is the very important formula. So this I took as equation number 6. This I will take it as equation number 7. Now I can substitute this T4 minus T1 divided by T3 minus T2 is equals to T1 by T2 in equation number 4. Now substitute equation 7 in equation 4. Now here what I will do is, I substitute this efficiency of Otto cycle is equals to 1 minus, in the place of T4 minus T1 divided by T3 minus T2, I can get it as T1 by T2. So we know that already we have a formula that T2 by T1 is equals to V1 by V2 to the power of gamma minus 1. This is a formula, already I told this one formula, T2 by T1 is equals to V1 by V2 to the power of gamma minus 1. Now I will write this T2 by T1. So I told that V1 by V2 can be taken as R to the power of gamma minus 1. But here you can see that we have T1 by T2. So that I will reverse this one. If I reverse this one, T1 by T2 can be written as 1 by R to the power of gamma minus 1. 1 by R to the power of gamma minus 1. Now what I will do, I will substitute this T1 by T2 here. So I will get efficiency of Otto cycle can be written as 1 minus T1 by T2. As I did the calculation here, so T1 by T2 can be written as 1 by R to the power of gamma minus 1. 1 by R to the power of gamma minus 1. This is the final efficiency of Otto cycle. Okay, so first we have to consider the efficiency formula. After considering the efficiency formula, we have to take it, supplied it, rejected everything. After that, we make a standard equation like this. Because efficiency of Otto cycle is equal to 1 minus T4 minus T1 divided by T3 minus T2. This is the first step. After determining this, heat addition and heat rejection, next you should go for the isentropic compression expansion process. After the isentropic expansion compression process, you should do the T-V ratios like this. As I told, T2 by T1 is equals to T1 by T2 by gamma minus 1. This ratio for both compression and expansion. After doing this, you have to equate like this. After that, you have to do this one. That is, you have to take 1 minus on both the sides. So that if you cancel, you get the same answer here. After this everything, you have to bring to a very simplified equation. T1 minus T4 is divided by T2 minus T3 is equal to T1 by T2. Now substitute this entire thing in the equation of the Otto cycle. So efficiency of Otto is equal to 1 minus T1 minus T1 by T2. So T1 by T2, if I do like this by the considering isentropic compression, I get R 1 by R to the power of gamma minus 1. The efficiency, A standard efficiency of Otto cycle is given by 1 minus 1 by R to the power of gamma minus 1. This is a standard one which can be used for the petrol engine. Mainly the Otto cycle principle is used for the petrol engine.